Okay everyone, this is going to be the world's first manual vacuum cleaner. So this is just the nozzle of the vacuum cleaner, nothing else. There is no back portion, there is no machine which is going to suck up, and I'll be cleaning this styrofoam mess with just the help of this nozzle. So what I'm going to be doing, I'll be rotating one of the ends, I'll be revolving it, and all the styrofoam balls will be sucked up from the other end and will come out again from the end which I am revolving. This is pure styrofoam, and so I'll be rotating it and all the balls are just going to come out. So here we go. I'll rotate it and you can see how the balls are actually going into the other end and it's coming out. You can also see that the styrofoam balls are also coming out of the end which I am rotating. So since I am pointing it towards the table, it's returning, but if I point it somewhere else, all the styrofoam is being sucked up and going somewhere else. Wow, this is amazing. I'm able to clean the whole table by just using the nozzle of the styrofoam, of the vacuum cleaner, nothing else. So there's a styrofoam ball, I'll just clean it and you can see how it goes and goes away. Now if I had attached a cup like thing on the end which I'm revolving, then I'll also be able to collect all the styrofoam particles. Now this is amazing. I never thought of that I can actually make a manual vacuum cleaner. Now let's go to another example. So now let's take the example of the sanitizing bottle. Now you might have noticed that when we pull the trigger of the bottle, the sanitizer comes out. But why? Even though we are pulling this trigger, so we are pushing the air inside the tube downwards, but the sanitizer still comes out like this. This is quite contradictory in layman terms. I'm just pulling with the help of the spring. I'm pushing the air downwards, but it's actually able to pull the sanitizer upwards. So I'm going to be telling you the reason behind both of these. Both of them have used the same principle. That's called the Bernoulli's principle. And Bernoulli expressed this principle with the help of an equation which I'll explain you right now. Now according to the law of conservation of energy, energy can neither be created nor be destroyed. It can just be transformed from one form to another form. For example, if a ball is rolling down, then its kinetic energy is increasing and the pressure and the potential energy is decreasing. And the sum of these two energy is always constant. But here's what Bernoulli said. He said that he also included one more type of energy called pressure energy. So he derived this equation that pressure energy plus kinetic energy, which is the energy stored in a moving object, plus the potential energy, which is the energy, in regard to the position of an object. And the sum of these energy is constant, which means that if I increase the kinetic energy, the other two energy, which are the potential and pressure energy, will automatically decrease. And for example, if I increase the pressure energy, the kinetic and potential energy will decrease. So this was the mathematical term which he encountered, and he derived his equation as pressure energy plus kinetic energy half mv square plus potential energy mgh is constant. So for example, if I'm increasing, for example, there are particles, material particles, and if they're accelerating, so since they're accelerating, the kinetic energy is increasing, so kinetic energy increases. So what's happening, so the potential energy will automatically decrease. Potential energy as well as pressure energy will automatically decrease. So over here in this region, a low pressure region is created. Okay, a low pressure region is created. So as we know, air or pressure in nature always moves from high pressure to low pressure. So there will be some force exerted onto these particles from outside as air moves from high pressure to low pressure. So there's the high pressure and low pressure over here. Air is moving from high pressure to low pressure, and it will automatically lift these particles. It will help in moving these particles away. It will generate some lift, some aerodynamic lift in the other direction. So air is moving from high pressure to low pressure, and will accelerate these particles due to the lift being created. Now this is the Bernoulli's principle, and now I'll explain you with reference to the other two examples. So in the case of this little vacuum cleaner, what's happening, I am rotating one end. So since it's rotating, it's accelerating the air molecules around it and creating a low pressure region at that end, which I am rotating. So at this region, low pressure is created. And at the other end, high pressure is created, which is moving the air from high pressure region to low pressure region, which means from here to there. And that's how I'm able to actually trap all the styrofoam balls to accelerate them into the other direction using the Bernoulli's principle. Let me show you it again. Over here I have these small pieces of paper. As you can see, they're just being sucked in, as the air is moving from high pressure to low pressure region. Now obviously this in actual vacuum cleaner, this is done more efficiently than the rate which I am doing, but they also use kind of the same principle. Now this type of vacuum cleaner can actually suck up things which have less mass, but if you take things which have a higher mass, well, it'll be way more difficult to suck in, because, well, you're not sucking that particular substance, but you're sucking the air. Let me show you how it's done. So for example, I have this bead. Now my manual vacuum cleaner will not be able to suck this up because it has a higher mass. In case of styrofoam balls and paper, they had a very low mass, so it was easier for me to suck them up. But in this case, I am not even able to move the bead. Now let's go to the next example which I showed you. Now in this case of the sanitizer, same Bernoulli's principle is being used. So the sanitizer, the upper portion of the sanitizer, which is attached to the tube, it has a spring. So when I'm triggering this, the spring is forcing the air molecules to move downwards. Since the air molecules are moving, increasing kinetic energy causes the region to be of low pressure. So there's a low pressure region inside this tube, while in the surrounding liquid, there's a high pressure region. So that as you know, always in nature, things move from high pressure to low pressure. That's why the sanitizer moves from the high pressure region to the low pressure region and up. Spraying, it helps in spraying. So both of these are actually the same principle. They use the same principle. Now Bernoulli's principle not only encounters these two phenomena, but also it accounts for how airplanes work. So airplanes, what they do, when they move, they try to decrease the speed of particles below them and increase the speed of air molecules above them by using aerodynamic structures. So since the air is moving at a faster rate above the airplanes, creating low pressure over here, due to which, as you know, air moves from high pressure to low pressure, so it's pushing the airplane in upward direction, generating aerodynamic lifts. And well, some scientists have also been trying to increase this lift by changing the structure of the airplane, by making them more aerodynamic and using some live examples like in sharks, which helps them to cut through the water by decreasing the drag efficiency. So Bernoulli's principle is very efficient. I hope you liked my video, and thank you.